I'd like to thank Heidi for giving me this chance to speak. I'd planned to come to this meeting for a couple of days, but it wasn't clear I'd get a chance to tell you a little about DARPA. So I'm with the Defense Sciences Office. Some of you may know we had our 60th anniversary bash last week in Maryland. DARPA was founded and has this overarching mission simply to prevent surprises, to prevent surprise attacks on the US and our allies. And it was prompted by the Sputnik event. The DSO office, Defense Sciences Office, considers itself the DARPA of DARPA in that we are allowed to look at somewhat out-of-the-box, slightly crazy ideas to see if there's anything to them that might present a threat to our defense organizations, to national security, basically, for us and our allies 10, 20, 30 years out. And we're very happy to investigate these topics. The P in DARPA, by the way, is projects, so we're project oriented. We're perfectly okay investing in projects to see if there's some real threat, likely or not, from an idea, and determine that there isn't one, that there's nothing there. That's okay, because that means our adversaries are not going to be after us using those ideas in the near future. So we invest in a range of different topics and ideas. Obviously, if we can identify breakthrough technologies that can benefit our armed forces and our allies, then we will exploit them. But we're also primarily engaged in preventing surprise. So negative results are good. We have the benefit as program managers working with performers and teams in seeing all the things that fail, but they will not publish because you probably can't even publish results that are failures. We want to know about the failures too. So DARPA is broken down, tell me if I'm in the way, is broken down into these offices. There's a biological technologies office which broke off of DSO about 4 years ago. I2O, you probably can't read this, mainly concerned with cyber. Microsystems technology, heavily into semiconductors and next generation electronics. STO, strategic technology office, a lot of communication, command, control work. And TTO, Tactical Technology Office, is really at the leading edge with, quote, the warfighter in providing systems support. Each office has an office director and a deputy office director, and they report to the director of the agency. So the hierarchy is fairly thin. I want to tell you a little bit about what my day is like, and I want to ask you for help because I'm interested in understanding more about propellantless propulsion and if there's a potential threat there or an opportunity there in the next 10, 20, 30 years. The overarching mission of DARPA can be broadly summarized in terms of three priority areas, and one of them is space. Space is the next battlefield, and owning space, managing space, being able to move things around in space is very important. A second primary area of interest right now, which is probably of less interest, is hypersonics. And a third key area which the agency announced last week it's investing a lot in over the next few years, a couple of $1 billion in the next few years, is artificial intelligence. Now those are very broad headings, but as program managers we have to be able to argue the case to the director of the agency and his team of military and government advisors that a program we want to run is consistent with the mission, the objectives of the overall agency. We would have already had to do that with our office director, but to get funding for a program, it's the director himself with his team who is thumbs up or thumbs down. And it can take several months for us to go through the steps from an idea for a project to a kind of desktop presentation to our peers, to formal presentations to our office leadership, until we get a chance to get up to the director's office and his team and make the pitch. And when that happens, we often get homework. They will come back to us and say, well, some of this is okay, but what about this and what about that? Sometimes they'll just say, no, it's not important enough, because even DARPA has a finite amount of money, and there are way more projects being proposed within the agency than could ever be funded. So priorities have to be made and arguments have to be made. So if we want to invest in an area, we are the champions as the program managers to have to do that. And a word about program managers. I was formerly an academic. I've been with London University, University of Massachusetts, University of North Carolina, and I only have this job because I was pushy trying to get my second or third DARPA grant, and I went to a proposers day with all these ideas, and the office director of DSO at the time said, well, why don't you just come here and be a program manager? Then you can argue for money internally and you can get the best people in the world to do the work you want to see done, that you're excited about. So we go there with several ideas in mind, which we develop and pitch to the director. But this particular area is one that I was presented with about 18 months ago and said, would you like, Fiddy, would you like to get interested in this and learn a bit more about it? Because maybe there's a potential threat there. And I've talked to several of you in the room over the last 18 months. I've visited a lot of places. I've talked to many other government agencies, including the intelligence community. And I think there is a case to be made that we should be digging deeper into this particular area. And I'll explain how all that will work in a moment. So I have to fit this propellantless propulsion concept, or something even more fundamental that kind of underlies it, into one of these broad categories for the office. That's not a big deal. I'm not worried about that. I have to make sure, so these are all the DSO program managers. I have to make sure it doesn't overlap or tread on the toes of activities any of them are currently engaged in. And I don't believe it will. And I have to make sure that I'm not stating the obvious to an agency which has poured actually a lot of money into similar topics over the last 60 years. Now the corporate memory is thin at DARPA. It's very difficult to actually dig back and find out who was funded to do what and what the outcomes were. It can be found, but some of it obviously becomes classified, some of it just gets spread out to government labs and is taken further. This is just a list of programs that have been released in the last couple of years, since November 2016. And what we're talking about here does not interact with anything particularly recent coming out of DSO. But this also shows you roughly how many programs are launched out of DSO each year. There are 9, 10 program managers, and we probably, if we really push, can get a couple of programs. So by program, I mean many millions of dollars. I mean a program that's going to consist of maybe 5 to 10 teams involving universities, defense contractors, and so on. Each team might have 4 or 5 principal investigators. And the program is judged based on a program goal. The project is all about the program manager having identified a goal. And the effort of all the teams is towards the goal. It's not competitive between the team members. Yes, Jim?
Yeah, question. In the case of NASA, it's our understanding, we have a phase 2 grant, NIAC. It's our understanding that the stuff that the grant pays for should be basically US. And we're in informal conversations right at the moment with Analog Devices International, one of their research operations in Ireland. And it's not something that is, I understand the rules of NASA, that we can get involved in paying them anything to do this. They're actually talking about investing their own resources. Under DARPA, is that the case? In other words, you're running a project, and were this, say, part of one of your programs, would it be a problem to go to Analog Devices with an incentive beyond them making a lot of money and getting some intellectual property out of it?
Yeah, no, that's a good question, and let me clarify that. So in DSO, we have a lot of what's called 6.1 money, which is money allocated for fundamental research. Fundamental research means there are no publication restrictions, and with the exception of a few countries in the world, maybe like Iran and North Korea, we will accept proposals from anywhere, and teams can be comprised of groups from anywhere, any countries. So in fact, one of my new programs, NLM, Professor Tamar is a sub-awardee to a PI who is in the UK, and that's all fine. Now, one thing to make sure I don't forget, I should say, is that DARPA structures, in particular in DSO, it structures its programs around phases. So my programs are typically like a phase 1A, phase 1B, phase 2, phase 3, 4 years. There may be some millions attached to that, but they're all cooperative agreements, which mean I'm hands-on, and we have 6-week calls, we have quarterly program reviews, we have 2 6-month reviews face-to-face with the whole team. Because twice a year I have to defend to the leadership that the progress is being made by all the teams for a given program towards reaching the goal. So the first phase is usually a base period and the funding is guaranteed. But under a cooperative agreement, year 2, year 3, year 4, these are options. And if I don't think progress is being made, I may not exercise the option for some of the teams. And worse than that, when I present to the director and I think everything's going really well, he says, "You're wasting taxpayers' money. I've got more important things to fund," and he'll kill the program. So there's no guarantee that you will be funded for the length of time you think you're getting funded for when the program begins. But just to repeat, it's a project with a goal, and the program manager's objective is to pull everyone together from the different teams and coordinate the effort towards achieving that goal. If we're moving towards reaching the goal, then all the teams are safe. It's not competitive. And it's part of DARPA's mission is to build communities, bring together groups from often very different backgrounds and create new fields. So the teaming and the result of the program, having created a new community and having shown there's no threat from what they were looking at, is a great outcome. Sorry.
For the last year or so, I've been involved with some Russians, and we're looking at things like cross fields for running hole thrusters and so on. So you just said that you would accept something if we did come in with a Russian co-worker.
As far as I know, yes.
Okay, now the next question I have is IP. What about patents and IP for the guys that put it in together in one of us?
Well, as part of the proposal submission process, you document all that. And so, I mean, the government doesn't want to interfere with those kinds of relationships, but the government typically would like to know it has access and is able to use what it's helped to support. Yeah. Oh, yes. Yes. You don't.
Stated in your cooperative agreement.
It's stated in the BAA is full of legal stuff and sections that you have to submit information to. So when you submit the proposal, it goes to me and my government team to review. We then make a technical assessment and a rough assessment of the costs and whether they're realistic or not. But then it goes to contracting management and legal and an army of others. Several floors of the building have people who will look at that kind of content, and they will engage with you if there's something in there that they think is unfair and unreasonable to the government.
Will it be as bad as NASA with the NSPARs, where you have 90 pages of documents that you got to go through and you got to be a lawyer's hand and all? Is it that bad, or is it the same?
It depends.
So you're political too.
Well, I'm gonna say I have seen cost and administrative volumes come in at 200-300 pages long, where the technical part might be 30.
Okay.
Yeah, but generally, it's the more savvy defense contractors who have all that information ready and put it in.
I mean, the reason I asked the question is I hate to be, as a contractor, putting in a proposal for 50 pages, you're breaking your chops, and it's zipped.
Right. Well, you know, it's always recommended to submit an executive summary first.
Yeah.
Although it makes our life both exciting but complicated, we like to have white papers and meetings with potential performers before the BAA appears. So everyone responding should have some idea of where the program manager is coming from and what they're looking for. And questions about IP are best brought up then. We can call the General Counsel's office. We have an army of people who could, before you submit, answer all these questions. Okay. So that you know.
A question, when it comes to this propellantless propulsion and talking about goals, do you already have like a goal statement in mind? In other words,
I'm coming to that.
Okay.
But I do need your help, because I think I do not have a background in this area. I'm more an electromagnetics guy, but I've got very interested in it, and I want to tell you how we develop that first slide deck for the internal presentation. And I want to tell you one other thing too. I'm not dodging your question, but a full-blown program, and there are only so many per year, does take quite a while between having the BAA published. Well, actually, it's probably 6 months between developing the idea and the BAA hitting the streets. Then you've got the abstract phase, you've got the proposer's day, you've got the submission deadline, you've got the reviewing to do. So, and then you have the kickoff, and there's a military clock ticking. So we have to have all these things done by a certain time. But it's still probably 120 days between the BAA coming out and the kickoff meeting. It's not a fast process. So DSO has developed a new kind of program which other offices are now adopting, and it's called disruptioneering. And disruptioneering, it's a maximum of 5 million for 18 months. And the guarantee is to go from the special notice, like a BAA hitting the streets, to the kickoff in 90 days, which of course is driving CMO and General Counsel crazy, but that's the commitment the directors made, because some things need to be looked at a little more speedily than they have been. So the disruptioneering has two phases. A phase 1 maybe 4 or 5 months, and then a phase 2. The phase 1 might be like 150 to 250k. Then phase 2 might be 700-800k. And the idea of disruptioneering is that there's a very specific question being asked, which the answer to which could then spawn a full-blown program, much better informed than perhaps some programs are, and that program could then get kicked off more quickly. Greg?
Yeah, having been worked on several DARPA programs, this particular kind of aspect might be working in the seedling or the super seedling. Does DSO handle those as well?
Well, that's a good question. A seedling is often like 300, 400k for 6 months or so, and this is bigger than that. And you can think of disruptioneering a bit like a super seedling.
Okay.
Some do think of it that way, except all the teams coming together are working on essentially the same goal. And some of there've been, I think, 6 or 7 disruptioneering so far. And in order to help with the speed up, they're no longer cooperative agreements. They're, for those of you who know these things, they're other transactions. And so they're going to be goal-driven. And this is another point where I would need some help in this context, because goal-driven means you get paid by meeting milestones. So you have a milestone at month 2, at month 5, and so on, and you submit a report showing you've met the milestones, then you get paid. And that can be managed much more quickly than the grants and contracts, cooperative agreements that we typically have. This is
That's called earned value.
Yeah, yes. Well, it's great for the taxpayer, right? So, let me skip.
Mike, just as an aside.
Yes.
Based upon interacting with the Chinese and the Russian system for getting funding in there, we've got to do it a lot quicker in terms of this process.
Yes, I agree. And sad to say, for some awards that have been made in the last 3-4 weeks, we're looking at contracts not being in place till January at the moment, because not only is there the fiscal year hiccup right now, end of fiscal year, but there's just a huge backlog. And these disruptioneerings, there was one recently on the physics of AI. It had a huge number of submissions, we can't say how many. Extra money was found to support more of them, and they're trying to meet this 90-day turnaround deadline.
Okay.
So
just want to raise the flag.
yes. Let me say one other thing as well, that there is 6.2 money. There's obviously classified work. There are ITAR issues, export control issues. But in
Control 6.2 also, right?
We do control 6.2 also. But we have, at least half of the DSO money is 6.1. We like to fund fundamental research. But we have had experiences recently with proposals coming in that how this is being recorded. Proposals coming in that are really very detailed in their defence relevance, to the point that even if we really like what they're proposing, we can't fund it with 6.1 money. We have to go and find 6.2 or 6.3 money, and it probably has to be, at the very least, publication restricted, or it may even have to be classified.
Or would you go through DDR&E, or would you go through congressional funding?
We would, it's the funding we have. We're not,
Internal funding.
it's all our, yes, internal. So sometimes we need to have people rewrite their proposals. Now, I need to be able to argue the relevance of the work to DARPA's mission internally, and you need to be able to say enough to help me understand that. But it's not always a good idea for you to be too specific in your proposals about that. So it's a grey area. It's a difficult situation. I am the first to admit that. But that's where the discussions beforehand can be very useful, because we kind of know what we want. But if you're really specific about, you know, how you can get somewhere to deploy something with these characteristics in the next 6 months, you know, whoa, that takes that proposal into a completely different category. And for us in DSO, a successful program is one that would migrate up to MTO or STO. If you're already writing something with that degree of specificity, you might as well submit it to them directly. So we're DSO and we're looking at fundamental questions. So what I wanted to, I'm running out of time. 5 minutes. So I'm going to jump. I was going to give an example of a program, but let me jump to this. So we all have exploration badges with the Hallmeyer Catechism printed on the back. And the Hallmeyer Catechism we're reminded of daily, and all programs, when we initiate them, start off with a slide deck that addresses these questions. And Hallmeyer was a DARPA director in the mid-70s. And with no jargon, because, you know, with all due respect, when you get up to the director's office and high-ranking military guys in there, they want to understand conceptually whether what you're proposing has any relevance to their world. And so they're very smart guys, and if they want to drill down and get detail, they will. But we have to be able to explain the idea without jargon in a fairly straightforward way. So we structure the presentations in terms of, and I don't know if you can read this at the back, what problem are you trying to solve? Why would solving it have any relevance to DoD? What are the key technical challenges that prevent a problem from being solved today? What is the new approach, and how can it overcome these apparent technical challenges? And what is the program plan? How are you going to execute this plan? So we're looking for answers to these questions, and when we review proposals coming in, we're thinking about the structure of the proposal in this framework. So this isn't true today yet, but in principle, you know, we're moving almost to this. If you can get the idea across in just a few slides, and it's compelling enough, you're all set.
Are you familiar with the NASA Breakthrough Propulsion Physics project which did this?
I'm familiar with some of the NASA Breakthrough Propulsion.
I led it, so
yes.
I can tell you because even on the process of how to do that middle ground between the pedantic disdain and the lunatic fringe and the constructive stuff as well as other things, so I can.
Right. Well, so let me wrap up by saying something about this program. So I have pitched ideas in this pun intended space to our office leadership. I've got the green light to move forward, at least with a disruptioneering. And I have some ideas from having talked to a number of government agencies and others about what is the project, what is the critical need right now to move things forward. And I'm not sure a lot of you will like this, but most of the inputs to me are relating to taking the theory further, doing more simulations, and getting a deeper understanding of a predictive kind of parametric model for the physical processes that might be responsible for propulsion. And understanding from those models whether within the next 10, 20 years there's a physical platform which might be capable of getting you up to 10 to maybe 100 newtons per kilowatt. Because that would make a difference. That would make a difference. But at the moment, you know, and I know there are two camps here, a friend at the back, Dr. Turner, we've had this discussion. I mean, the proof is in the pudding, so if you're doing a convincing experiment, no one's going to argue with that, even if it's not entirely clear what's going on. And the forces on me have put me in a different camp, saying, I want to be able to predict what might be possible based on a physical mechanism, and then use that to inform an experiment design. And I want to do the experiment then to see if it fits that theoretical prediction. I worry about doing more experiments and making, you know, bigger, better replicas of the same if we still aren't entirely sure we've got our arms around all the parameters involved. And so, you know, what problem to me at the moment, if I had to articulate it, but I'd love to hear from you, and nothing is in stone right now, but to me, what problem am I trying to solve? I see from all of the efforts in other countries, allies and non-allies, efforts in this space as being summed up I would sum it up this way, that gravitational and electromagnetic potentials permeate the universe, connecting matter. Is it possible to harvest energy or momentum from this background? That's it. That would be my first question. Now, it may not seem very sophisticated to many of you, but this is where I am right now, and this is where I'd like some help and some feedback to maybe tune that, refine it. But I'm really pushing hard to launch either a disruptioneering or a program somehow related to these topics in the next 3-4 months, if I'm allowed to, and if I can sell it internally.
There's a basic viewpoint about government agents. For example, what you guys would like to see is not so much as an analysis, but a piece of hardware sitting on your desk.
Not true in DSO.
Okay, well, what I was going to ask is, if you looked at what you saw that Jim did, that probably cost $100,000 to start.
Mm-hmm.
Okay.
Right, but I mean, I've talked to people in TTO. I know many of you have, like Jess Sponable, Gordon Resler. They have thought about this in the technology offices.
Where is Jeff now?
Jess is
Just works at aerospace.
there you go. There's not. They are kicking it back to DSO because there are still a lot of fundamental questions they feel need to be answered in order to take it to a level where they would invest much more than we would in taking it further. Great.
The support from places like Space and Missile Command, Space and Missile Center, does that help proposals go through the process if there seems to be a military utility?
I draw on people from lots of government labs to be on my government advisory team, so they get involved in helping to shape the BAA, reviewing the proposals. they're at the quarterly program reviews and the 6-month reviews, and then they become potential transition partners at some point. But in terms of the funding, we rarely kind of co-fund something. It's not impossible, but we rarely do that. And there's also, I have to be careful when I'm presenting to leadership to drop too many names of other agencies, because they will say, well, you know, our dollars are precious. We can do the really high risk things with our dollars. If they're already interested in it, let them do it. That happens. And the other thing is, if I'm too crazy with my ideas, they'll say, this is starting to leave the realm of DOD and national security. NSF should be funding this.
Yeah, did I hear correctly that what they are looking for, what you are looking for, is a better theoretical formulation with a numerical model that you predicted?
I'm assuming, because the equations are so tough, that some numerical simulation might be needed, but I'm not saying it has to be. I need a parametric predictive model of some kind.
So let's say that one has such a model, and it takes a fair amount of computing time, and you have predicted things in the past. What is that enough? What is it?
I want to be able to know that it's physically possible to generate those kinds of thrusts in some way. I'm not wedded to any particular physical platform at the moment. I want to know that physically it's possible, because then either we or one of the other offices can think about, well, okay, how do we actually do that?
So what will it take you to convince you that is meant? That's what is not clear to me. Because several of the people have theoretical models.
Well, I think, you know, much as I'm a believer that there is established science, there are experts out there, and we talked earlier about the APS meeting, and so you have big names in fields who kind of propagate certain ways of thinking about things, and they may well be the best way to think about things. But I'm quite sure, looking at the history of mankind, it hasn't been that long that people really thought that the sun went round the earth. It hasn't been that long since quantum theory kicked in terms of a scientific history. I don't think that we know everything by any means. So looking at theories that are a little different, maybe challenge some of the existing approaches, but may show a path towards how to develop a system with this capability, we would be interested in, because they're either completely wrong and then we can sleep easy and know there's no threat there, or they really do open up a new branch of physics and a new way of thinking about things. So it's a win-win. So I'm looking for a vision and a prediction of a capability, and it doesn't have to be through the traditional approaches. But I completely understand that if it is, and you're seeing something in general relativity and a way of breaking the problem down that points towards how you could achieve certain thrust power ratios, and to know it's possible on paper, maybe followed up with a simulation, and then maybe abstract a lab experiment which might not even be directly concerned with a thrust-based experiment, but it could indirectly confirm the model somehow. That would be fine. Yes?
So as Lance pointed out at the beginning, you know, there's a very polarizing view of just about anything brought up this way, and you know, how you pick your reviewers might influence the ability to progress, but that's not my real comment. My real question is, are you still open to the idea of maybe, you know, having some sort of workshop or forum where we can explore explore how to define reasonable questions and a way forward?
We talked about this,
We did, but I mean,
and
still,
the thing is, if we had a workshop, who would I invite?
exactly.
That's
And so I would rather go down the DARPA path of coming up with the best, the most comprehensive, the most sensible program goal I can. I want to ask a question, the answer to which informs me about a number of different things. I don't want someone to rock. I don't want to just be told, well, you know, clearly they're the leader in the field, you should give them all the money. I'm looking for new ideas and new approaches. So that's why, you know, this what problem are you going to solve needs to be thought about and articulated very carefully.
Well, that's the process that you're going for, because I had to go through that myself, and about how do you define the problem well enough, and what do you ask for, and how do you evaluate. So I did go through that, and I can share that.
Well,
On these specific
I'm going to probably hear from all of you, but I'm talking to lots of other people as well. I'm talking to quantum theorists, quantum field theorists, people from very different communities who don't even have a concept of propellantless propulsion,
Yes.
but they're deeply immersed in some mathematical aspect of what I think is relevant to all of this. And they can, in a bigger team, perhaps bring some new dimensions to the effort. So that's where I am. I'm sorry I took longer than promised.